All right, so today we're going to be looking into something pretty fundamental for anyone who's, keeping an eye on AI and how it's doing in research. Like, can we actually trust AI agents to independently validate and build on, the latest scientific breakthroughs? So we're going to be talking about this new benchmark called PaperBench.
Okay.
And it's been designed to answer exactly that question.
Interesting.
We've got a ton of materials here laying out the goals of this benchmark and also some of the initial findings they've gotten.
It's a big question, right? Like, can AI actually do real research?
Yeah.
And what I think is so interesting about PaperBench is just how rigorous their approach is.
Yeah.
They're really demanding a lot from these AI systems in terms of replicating cutting-edge work.
Right, like actually doing the work, not just talking about it.
Exactly.
So the AI agent is given a research paper. And it basically has to go from understanding the main ideas all the way to developing a working code base.
Wow.
And then reproducing the experimental results that the paper reported.
So it's like the whole research process from start to finish.
Exactly. And, even for experienced human researchers, this can take days.
Oh, yeah, for sure.
So right away, this benchmark is showing us what a huge challenge this is for AI.
Definitely. And they're not using just any old research papers either.
Right. They're really pushing the limits here.
Yeah, they picked 20 papers from ICML 2024.
And those are all spotlight and oral presentations too, right?
That's right.
So this is like top-tier machine learning research.
Cutting edge stuff, yeah.
And the fact that they're spanning 12 different ML topics, that's huge.
It is. It's like deep reinforcement learning, probabilistic methods, all sorts of stuff.
So they're really testing whether AI can handle the most current research out there.
It's a real comprehensive test.
And what's really cool is how they design their evaluation criteria.
Okay, so how are they actually judging whether an AI agent can do this?
Well, for each of the 20 papers, they developed these really detailed rubrics. And they did this in collaboration with the original authors of the papers.
Oh, that's smart. So they're making sure the benchmark is actually aligned with what the researchers themselves consider important.
Exactly. It's not just about, some surface level understanding.
Right. It has to be about actually achieving the core scientific contributions of the paper.
Yeah, as defined by the people who wrote it in the first place.
I like that a lot.
And it's not just some general assessment either.
Okay, how specific are we talking?
Well, across all 20 papers, there are over 8,000 individually gradable tasks.
Wow, over 8,000.
8,316 to be exact.
That's incredible, that level of detail.
It's really amazing. And that level of detail allows them to see exactly where these AI agents are doing well. And even more importantly, where they're falling short.
Right, because that's where the real insights are going to be.
Exactly.
But can you imagine actually trying to assess all those replication attempts manually?
Oh my gosh, yeah. The paper says it could take a human evaluator hours just for one attempt.
Hours for just one?
Yeah, it'd be a massive undertaking.
So how do they solve that?
Well, they came up with a really clever solution.
Okay, I'm intrigued.
They used large language model-based judges.
Oh, wow. So AI judging AI.
Exactly. And these judges automate the grading process using those really detailed rubrics we talked about.
That's a pretty neat way to deal with evaluating something this complex at such a large scale.
Yeah, it really is.
But that does raise another question.
What's that?
How do we know those AI judges are any good?
That is a very good point. That's like evaluating AI with AI.
Exactly. How can we trust the results?
Well, to make sure the automated judges are accurate, they actually created a separate benchmark called judgeable.
So a benchmark for the benchmarks, a meta?
Yeah, kind of. And judgeable specifically looks at how well the LLM-based judges line up with human evaluations.
Okay, so like comparing the AI judges against human judges to see how much they agree.
Exactly. And the best performing judge on judgeable got an F1 score of 0.83.
0.83. That's not perfect agreement with humans, but it's pretty darn close.
Right. It's not perfect, but it does suggest that these AI judges are surprisingly robust.
Yeah, and for doing evaluations on this scale, that scalability is crucial.
Absolutely.
It's really interesting to think about, too. It's not just that AI is the subject of this evaluation.
Yeah.
It's also a key tool in making the evaluation possible in the first place.
So we've got this ambitious benchmark focusing on cutting-edge research.
Yeah.
And this whole sophisticated evaluation framework. So what did they actually find when they put some of the current AI models to the test?
Well, the main finding is that AI still has a long way to go before it can truly do research on its own.
Okay, so how did the models perform?
Even the best performing agent they tested, which was Claude 3.5 Sonnet, new, and it was using publicly available tools and frameworks, even that only got an average replication score of 21% across all 20 papers.
21%. So basically only succeeding in about a fifth of the tasks.
Yeah. And remember, these are state-of-the-art models we're talking about.
It really puts things in perspective, doesn't it?
It does. And they also had a baseline using experienced human researchers.
Oh, that's a great comparison point.
Yeah. They had ML PhD students try to do the same replication tasks, and they gave them 48 hours to work on it.
Okay. A good amount of time.
And on their best attempts, those human experts got an average replication score of 41.4%.
So more than double what the best AI agent could do.
Yeah, and when you compare that to how one of the AI models O1 did on the same set of papers, it only got 26.6%.
That's a pretty significant gap.
It really highlights how far AI still has to go to catch up to humans in this kind of complex research work.
It does sound like the models hit some major roadblocks.
They did. There were several key limitations that became really clear.
Like what?
Well, one was that the AI agents often stopped working on a problem too early.
Oh, interesting. So they'd give up before they actually had to.
Yeah, they'd say the replication was complete or that there was some error they couldn't fix.
But there was actually still time left.
Right, and there might have been other things they could have tried.
So they weren't really thinking about the whole problem, just like the immediate steps.
Exactly. It seems like they're not so good at what you might call long horizon strategizing.
Right, so they can't plan out a whole sequence of steps.
And carry them out over an extended period of time to reach a complex goal.
Which is essential for research, right?
Absolutely. Research is all about iteration and troubleshooting.
So even if a model can do individual coding tasks, well, it might not have the kind of project management skill.
And the persistence.
Yeah, that's needed for the whole research process.
It's like they're missing the big picture.
Yes, exactly. And they also had problems with using tools effectively.
Oh, yeah, especially one of the model's O3 Mini.
What kind of problems?
Things like interacting with the operating system shell correctly, executing Python code, using web browsing effectively.
Wow, so pretty basic stuff.
And even just being able to process and extract information from long technical documents.
Which is like Research 101, right?
It is. And those are all really crucial skills for being able to do research and experimentation on your own.
Yeah, definitely.
Now, they also introduced a simpler version of the benchmark called PaperBench Code-Dev.
Oh, what's that all about?
Well, they realized that running the full PaperBench, it takes a lot of computing resources and time.
Yeah, that makes sense.
So they developed this Code-Dev version as a more accessible way to test things out.
Sorry.
And this version just focuses on evaluating whether the AI agent can generate the right code base.
So it's like the first part of the process?
Exactly. It doesn't require the agent to actually run the code and reproduce the results.
So it's not a full test of replication?
Right, but it's a more practical way to assess just the coding abilities.
Okay, so less comprehensive, but maybe more useful for a broader assessment.
Yeah, that's the idea. And it's also a lot easier for people to use because you don't need special hardware to run complex experiments.
Right. And it's cheaper to evaluate, too, because it relies on those LLM judges.
Exactly. So it's a good way to get a quick sense of how well these models can code.
And do they see any big differences in performance on this Code-Dev version?
They did. One of the models, O1, scored a lot higher on this one.
How much higher?
It got a 43.4% on the Code-Dev benchmark.
Wow. So a big jump from its score on the full PaperBench.
Yeah, and I think that's really telling.
What do you think it tells us?
Well, it shows that there's a big difference between being able to understand a research paper enough to write code and actually being able to get that code to run correctly and reproduce the results.
So the code generation part might be further along than the actual execution and debugging part.
Exactly, and that's a really important distinction to make.
And the way they structure those evaluation rubrics, that gives us even more insight, too.
Yeah, tell me more about that.
Well, it's not just a simple checklist. They organize it hierarchically.
Okay, so like a tree structure.
Exactly.
Yeah.
So the main goal of replication is broken down into more and more specific requirements.
So it starts broad and gets increasingly specific.
You're right. And each of those requirements, especially the most granular ones, they're given weights.
And those weights reflect how important they are to the whole replication.
Exactly. So it's really nuanced.
And within those rubrics, they were assessing different categories of requirements, right?
Yeah. There were three main types.
Okay, what were they?
Result match, execution,
okay,
and code development.
So they're looking at different stages of the research process.
Exactly.
So what does result match actually assess?
That looks at whether the AI's submission actually reproduced a specific result from the paper.
Okay, so like a quantitative result or maybe a qualitative finding.
Exactly. And then execution, nodes those check if certain events or outputs happened when the AI's reproduction script was run.
So making sure the code actually executes as expected.
Yeah. And finally, code development nodes, those evaluate the actual source code itself.
To see if it correctly implements what the paper was trying to do.
Right. So it's a really holistic evaluation looking at all these different parts of the research process.
It sounds like it. And how do these AI judges actually do these assessments for each type of requirement?
Well, it depends on the type of requirement.
Okay, so tell me about result match first.
For result match, the judge looks at the Reproduce.sh script.
Okay, so the script that runs the experiment.
Exactly. And then the reproduce.log file.
Which logs everything that happens during execution.
And any output files or plots that were generated.
Okay, so the judge has all the information about what the code did and what it produced.
Right. And then for execution nodes, the judge looks at the reproduce.sh,
okay,
the reproduce.log, and the source code.
So it can check if the code ran as expected.
Yeah, and for code development, the main focus is the source code itself. Although they can also look at readme files or documentation.
So they're really making sure the code itself is up to snuff.
Exactly. And one thing that's really important to note, if an agent can't even produce a basic reproduce.sh script.
So it can't even start the experiment.
Right. It automatically gets a score of 0 on all the execution and result match requirements.
Oh, wow. So it's game over right from the start.
Pretty much it highlights just how fundamental it is to be able to actually initiate that experimental process.
Makes sense. You can't validate results if you can't even run the code.
Exactly.
So with all that said, were there any rules the AI agents had to follow during the benchmark?
Yeah, they had to stick to some guidelines.
To make sure things were fair.
Right, so they were allowed to use the internet to access information in libraries.
Oh, okay, so they could look things up if they needed to.
Yeah, but there was one really important restriction.
What was that?
They weren't allowed to look at the original author's code.
Oh, okay.
Or any other publicly available replications of the paper.
So they couldn't cheat by looking at existing solutions.
Exactly. The whole point was to see if they could understand the paper and implement the research from scratch.
Based only on the information in the paper itself.
Yeah, so no shortcuts allowed.
So they were really testing their independent research and engineering skills.
Exactly.
And, in the end, PaperBench is giving us a really important tool for measuring how far AI has come in terms of autonomy.
And it's in a really demanding domain too, right?
Oh, yeah. Machine learning research is about as complex as it gets.
So if AI can eventually master this kind of autonomous replication, it could have a huge impact on how quickly we make scientific discoveries.
And not just in machine learning, but in all sorts of fields.
Absolutely. But as the researchers themselves point out, this also comes with some important things to think about.
What do you mean?
Well, if AI can replicate and maybe even extend cutting-edge research on its own, that raises questions about how we develop and deploy these tools responsibly.
Right, because this is powerful technology.
It is, and PaperBench is providing a way for us to measure these capabilities as they develop.
So that we can understand both the potential benefits and the potential risks.
Exactly. It's really pushing us to think critically about how AI might change the future of research.
And what safeguards we might need as AI becomes more and more autonomous.
Some really thought-provoking findings from this PaperBench study.
It is fascinating work.
Clearly, we're still in the early stages of AI autonomy in research.
Yeah, there's a lot more work to be done.
But this benchmark gives us a really rigorous way to track our progress.
And it helps us ask the right questions along the way.
Well, thanks so much for breaking this down with me. It's been a great conversation.
My pleasure. I always enjoy these deep dives.
And for those of you listening out there, what are your thoughts on all of this?
Yeah, what stands out to you about AI's limitations in research right now?
It's definitely something to keep an eye on as AI continues to evolve.
Absolutely. This is just the beginning.
So much more to come.
I can't wait to see what the future holds.
Me neither. All right. Thanks, everyone, for joining us.
See you next time.
Bye.